All right, NYP Physics, let's go through some of these problems to help you study for your exam on Friday. Now, not all of this stuff is going to be on your exam, but a significant portion of questions will be there for you to go through in terms of forces, energy, and motion. Okay, so here we go. So, how do we sketch a displacement time graph for a dog starting at 1.2 meters from a reference point, walking slowly away at a constant velocity of 3 seconds, stopping for 5 seconds and backing up? So first of all, we have to have my displacement time. This is going to be in meters. And if it's starting at 1.2 meters, it's going to be somewhere up here. Okay, and if it's walking slowly at a constant velocity, it's going to look something like that. This is going to be 3 seconds. It stops for 5 seconds. Therefore, it's a flat line. It's not moving. And that'll be 8 seconds. And then it backs up at half the speed for 2 seconds. So what I need to do is I need to look at the slope here. Okay, that slope is quite steep. It needs to be half as steep as that slope for 2 seconds. So I'm just going to approximate half as steep for 2 seconds. So it's not going to reach the same. If it's half as steep, it's just going to reach halfway in that, or not halfway, maybe a little less, a little bit more than that, because this is a 3 second interval. So it might be somewhere around there. Okay, but I could have calculated that if I looked at the slope here. Okay, and that's what that graph would look like. And then if it stopped, it would look something like that. Below is a picture of a ticker tape experiment where a car drops paint on paper at regular intervals. For example, 1 drop per 0.5 seconds. Match the ticker tape to the appropriate position time graph below. Okay, and so we talked about this in class. Ticker tape means that the car is moving and dropping every 0.5 seconds. Okay, so the greater the space between the dots, the greater the displacement over that time interval, the faster the car would be moving. Okay, in this case, I only have 1 dot, so I can't see whether it's stopped or moving. So let's just imagine this one is stopped. Okay, and then this one, the dots are closest together, so I would say the speed is the slowest. This one is slightly further, and this one is the fastest. So which of these graphs show stopped? Okay, that one is stopped, so this is going to be your stopped one, that's C. Okay, and then the steeper the slope, the faster the car is going. So let's go from top to bottom. The fastest, which has the steepest slope, is going to be with the one with the most space between the dots. So that's going to be A. Okay, and then this is going to be B, and this is going to be D. During the motion depicted for each letter stage in the graph below, also calculate the velocity of the object at each stage. Okay, so here, remember, velocity is equal to my change in displacement over the change in time. So my velocity is going to be the change in displacement. So what was the change in displacement at A? That's going to be 16 minus 0 divided by 4 seconds. So the velocity for A is going to be 4 meters per second. Okay? The velocity for B is going to be equal to 0 meters per second because it didn't change displacement at all. And then the velocity for C is going to be 16. Okay, so it's going to be, is it 16 minus 0 or 0 minus 16? It's going to be 0 meters minus 16 meters. Okay, because that's my final, this is my final displacement, that's my initial displacement, divided by time, which is going to be 8 seconds. Okay, so velocity for C is going to be negative 2 meters per second. Now the important thing you need to understand is, what is that negative? Negative means that the velocity is going in the opposite direction, which is represented by the slope. So the slope of the lines here in that graph represent velocity. Match each velocity time graph below with the correct statement: negative acceleration, positive acceleration, moving with 0 acceleration, and a stationary object. Whenever I'm looking at graphs, I need to look at the axes. This is velocity, and that's time. So all of these are velocity time graphs. So if velocity doesn't change, we would say that that velocity is constant over time. So this is the graph showing constant velocity. All right, so which one of these is constant velocity? It's moving, it can't be a stationary object. So it's moving, but it has constant velocity, no acceleration. So this is going to be 3, okay? And then let's take a look at the other ones. Okay, here my velocity is 0 for the whole time. I have a constant velocity of 0, so I'm not moving anywhere. That is 4. Here my velocity is increasing over time. That means I'm accelerating, so it's positive acceleration. And here my velocity is decreasing over time, or going in the opposite direction, so I have negative acceleration. Okay, describe the motion of the object as illustrated in the graph below. Well, this motion is going to be a position time graph. That's change in my displacement over time. Okay, so that would mean, what do I have to look at when I'm looking at a graph like this? I'm looking at the shape of the line, the slope of that line. What does the slope mean? The slope of a position time graph is the change in position over change in time, which is velocity. Okay, so slope equals velocity for a position time graph. And the area doesn't mean anything. That's position times time. So what's happening to the slope of that line? The slope is changing, which means that my velocity is changing. If my velocity is changing over time, that means I'm getting acceleration. Okay, so that is negative acceleration. It's accelerating in the negative direction. All right, in your notebook, complete the velocity time graph below. Okay, so how would I get the velocity time graph for that? Okay, well, this section is acceleration, and this section looks like a straight line, so that's like constant velocity-ish. Okay, in order to get the acceleration, I need to calculate the slope at these time points. The slope at those time points, represent the velocity. So slope represents velocity. Okay, and how do I get the slope? Slope is the delta y over the delta x. So if I measured the change in x and the change in y by looking at these graphs, I'd be able to calculate it. So using a ruler, you'd be able to do that. All right, and then I'd be able to plug these numbers into here. So I'd have to physically use a ruler and measure the slope of those lines by measuring the change in y over the change in x. Okay, the slope here is 0. I got that one for sure. Okay, but the others I would have to actually put in a ruler measurement to be able to get those slopes. What does the area under a velocity time graph represent? So the area under a velocity time graph, that area is equal to, area is equal to this axis times that axis, right? So area is equal to velocity times time. What is velocity times time? Area is equal to meters per second times seconds, which will give me meters. So the area under that graph is meters. Okay, section 2 will be in the next video.